All right, let's look at equilibrium, and we're going to do all questions in exemplar, the objective ones. Let's get started. Pehla sawal. We know that the relationship between Kp and Kc is something. Oh, okay, they've given a relationship. What will be the value of delta n? Okay, ये थोड़ा ज़्यादा simple सवाल हो गया. This is not going to count. You have 1 and 1, so it's just simply 2. That's the first one. Let's go to the next one. For the reaction H2 plus I2 gives 2Hi, the standard free energy is delta G greater than 0. What is equilibrium constant? You just have to do this. Yeah, use this standard expression that you have. Remember that if it is G naught, then it's K. If it's not, then it's just RT ln Q. And you use this in the derivation of electrochem stuff. Anyway, we're not worried about that right now. So if this is greater than 0, that means that this right here is going to be less than 0, correct? Because this thing is negative. Sometimes students get confused on this. Okay, so delta G greater than 0. Okay, negative or negative becomes positives. So K, or rather ln K, must be less than 0. Now why would that happen? So if ln K is negative, that means that K is less than 1. That is the answer that I would like to select over here. Are you familiar with the log properties? We're just using that to do this, okay? Nothing fancy. Please revise log if this seems weird to you. Which of the following is not a general characteristic, third question, of equilibria involving physical processes? Let's read them out. Equilibrium is possible only in a closed system, given temperature. Sure, this works. All measurable properties of system remain constant. ये भी सही लग रहा है. All physical processes, no. This is not correct. Physical they will continue. Like liquid becomes gas and all of that. Yeah, that's like a physical equilibrium. This works. This one's wrong. This is your answer right here. Don't worry about the next one. We can read the next option, but it doesn't matter. The opposing processes occur at the same rate. Yeah, sure. Rate of the forward reaction is equal to rate of the backward reaction. That's the definition of equilibrium. All right, fourth question. Yeah, we're rushing through this, huh? Okay, great. BCl 5, and that's the kind of time you have for JEE and NEET questions anyway. So I think we are doing good time on this. PCl 5 plus PCl 3 and Cl2 are in equilibrium. Okay, let's write the equation down before we do anything else. PCl3 gives you PCl5, and all of these are gases. Don't forget to write that down. Okay, cool. 500 Kelvin, closed container, concentrations are given. Okay, Kc की value निकालनी है. Oh, for the opposite reaction. Great, I wrote it down, but we have to find Kc for this. So anyway, Kc here is going to be simply this, and remember, we are talking about concentration terms, okay? So please don't do partial pressure and all that. I know these are gases, but look at what the question is asking for. No conversion, nothing, just straightforward question. Okay, so Cl2 is this, right? Let me put this as 3 and 3, and this is 2, and this is 2, and this is 1, and this is 1. Okay, so basically I'm going to do 2 into 3 divided by 1. That should be the value of Kc, right? All right, so that's 1.2 into 10 power minus 3 whole squared divided by 0.8 into 10 power minus 3. I don't have to worry about the actual number because look at the options, okay? I only have two options that have 10 power minus 3. So let me scratch that out, and the answer should be 2 because K doesn't have units, man. I know you're going to be tempted to say, oh no, the unit of K is this. No, K does not have units, okay? This is a basic idea of equilibrium. I know in school, some people have been asking you things like unit of K and all that. No, K does not have units, okay? The idea has to do with activity. I have covered that in a little bit of detail in my theory session. You can check it out, but read up on activity if you want to know why K does not have units. The answer should be this. You can check it out. Okay, cool. Which of the following statements is incorrect? Kaunsa incorrect hai? Don't like these questions. Incorrect, okay. In equilibrium mixture of ice and water kept in perfectly insulated flask, mass of ice and water does not change with time. Yeah, sure. Why would the mass change with time? This is correct and hence not the right answer. Okay. The intensity of red color increases when oxalic acid is added to a solution containing iron 3 nitrate and potassium thiocyanate. Wow, that's a tough one. We'll see how to deal with that. On addition of catalyst, the equilibrium constant value is not affected. Yeah, this is right and hence not correct because we got to figure out the incorrect option. Equilibrium constant for a reaction with negative delta H value decreases as the temperature increases. Okay, quite a lot. Equilibrium constant matlab ki K for a reaction with negative delta H value, which means exothermic, right? Okay, decreases with as the temperature increases. हाँ ये भी सही है. This is right. Right. K will decrease as temperature increases. Sure, if we had endothermic reaction, then K would increase with an increase in temperature. Yeah, that sense. So interestingly, this is the wrong answer. But why is this wrong? Intensity of red color increases when oxalic acid. Wow, let's write that down. H2C2O4 is added to a solution containing Fe3 nitrate. Okay, FeNO3 whole thrice. And उसमें और क्या है? And potassium thiocyanate. This is a complicated idea, right? It looks scary, but here's the deal, right? If you want to do MCQs, the quick way to do this is know that this is wrong and move on. Sure, when you're doing theory, we can discuss in detail, and maybe at the end of all of these questions, we can come back to this. But for now, you know for sure that this is the incorrect one because the other three are correct. That's another thing you got to keep in mind when you're doing MCQs. Yeah, you don't necessarily have to know everything in a test. Learning phase alag hai. Testing phase mein you got to be brutal, you've got to get to the answer. We'll explore this later if we need to. Abhi ke liye, let's move on. Because you got the right answer, right? Just check if this is correct. Yeah, I think 5-2 makes sense. When hydrochloric acid is added to cobalt nitrate at room temperature, the following reaction takes place. Okay, HCl, hence you get Cl minus to cobalt nitrate. Wow, look at this. You got a lot of scary things. You see that nitrate is not written in this equation at all. Why is that? This is a spectator ion, so we don't have to worry about this. Okay, if you don't remember what spectator ions are, read up redox. Basically, things that don't really take part in a reaction, before and after, they still stay in solution. Okay, and why is it COH2O whole 6 if you have not done coordination compounds? This is what happens. That's why you get colored stuff. Yeah, coordination compounds. This will be clear if you don't know this already. Okay, the reaction mixture becomes blue. Why? Because does the oxidation state of CO change? Let's see. Does that happen? Or what is happening here? Or is it just something else? Oh, the coordination sphere, instead of H2O, from octahedral, it becomes tetrahedral. That's for sure. But does anything else change? Let's just quickly check. You've got cobalt, which is 3+. Okay. Here, what is cobalt? I feel that if you got cobalt plus 4 into Cl minus equal to -2, and this has an oxidation state of -1. So, yeah, I think that cobalt now has a +2 state. Oh, so this is getting reduced. Interesting. So shouldn't something else be oxidized? Think about it. How is this possible? If this is CO3+ and this is CO2+, this is getting reduced. What is getting oxidized? Okay, that's weird. Okay, but can we? Okay, but that's one thing to keep in mind, and let me know if you can figure this out. Again, we'll address this towards the end. But let's try and answer this question without all of this. Yeah, this was just something curious that I thought we should discuss. But what is the question actually asking for? On the basis of this information, mark the correct answer. Delta H greater than 0, less than 0, equal to 0. Okay, cool. How are you going to figure this out? If delta H is greater than 0, less than 0 or not? Is there some way to tell for sure? Now this seems like a tricky question. I may be tempted to mark 4. That's my initial take. What do you think about this? Let me know. And how are you going to know if this is going to be this or not? Oh, okay. Be careful. Read this question properly. I'm going to change the color of this pen very quickly. I know, right? This is important. On cooling the mixture, it becomes pink. Now, this is the biggest hint over here. On cooling the mixture. So, what am I doing when I cool the mixture? I am removing heat. Cooling means removing heat. Okay. So, in a way, removing heat makes the reaction go backward. Okay. If I add heat, just slowing it down. I'm writing on the right hand side now. Okay. Let me write in the same place. Okay. When I add heat, that means that the reaction would go forward. Okay. Now, do you remember what we can do from this? If I take delta H, and this is a cheap trick, right? As a reaction, or if I take heat as something as a part of the reaction, and I'm saying that Q on the left hand side, I add heat and the reaction goes forward. That's what this means, right? So this is an endothermic reaction. Do you remember these weird tricks from the theory sessions? If you don't, please revise that. But that's why I'm pretty sure that this is not the right answer. I'm going to remove all of this, and 1 is the right answer. I know that this screen has got a little bit crowded, but focus on the stuff that I've marked in yellow. On cooling the mixture, it becomes pink, which means cooling is removing heat. On removing heat, the reaction goes backward. It becomes pink, which means on adding heat, it goes forward. Removing heat is a little bit complicated, right? I can also write minus Q on this side, on the right hand side, but that gets confusing. That's why I'm talking about addition of heat. So this is the overall reaction, Q plus this, okay. Now, if you remember endothermic reactions, this is how we defined them. If you write LHS, heat, then that's endo. If I write RHS, heat, that's exothermic. That's another way of, because it's saying that I need to add heat for the reaction to happen, endothermic. Heat is produced as a part of the reactants, exothermic. That's all that this question is about. About the redox ideas, just something for you to think about. We'll address it later. If we need to, okay. But I'm going to leave this as an open-ended thing for you to just explore. I'm not able to figure out what the other thing is. Can you figure out where oxidation is happening? Or maybe that's part of something that's not written over here. Anyway, the focus is we figured this question out. The pH of neutral water at 25 degrees Celsius. These are nice questions. Exemplars, nice questions. Moving on to 7th question. pH of neutral water is some value. Temperature increases, ionization of water increases. However, concentration H plus ion. Yeah, cool. What will the pH of pure water? 60. Yeah, it's not going to change. Why would it change? Okay, cool. Oh. What will be the pH of pure water at 60 degrees Celsius? The pH will change. Yeah, of course it will change. Why will it not change? I'll talk about that. I was going to say that the solution still stays neutral. Okay. Why? Because I have not changed the H plus or OH minus concentration. It stays neutral, but that neutral value is going to be different. What do I mean? Okay. I'm going to again use that nice yellow color to highlight the important thing. As the temperature increases, ionization of water increases. That is the main thing over here. Okay, so let's write that down. Too much? Let's write that down. Ionization of water. So this is the expression that we're talking about. This equation should represent the ionization of water. Okay. So as I increase the temperature, this reaction goes forward. That's what we are saying. If the reaction goes forward, then the K value will increase, which means that this is an endothermic reaction. Okay, just write down everything we know, slowing things down a little bit. So if K increases, then ln K would decrease capital K. Okay. And what was K anyway, right? I had Kw, basically that, Kw, right? So Kw, say, dash is greater than Kw, which was 10 power minus 14, which means that ln Kw dash is going to be lower, negative ln, obviously. Negative ln Kw dash is going to be lower than negative ln Kw. Okay. I forgot to add this negative sign. That's the only reason it will be lower. Why else would it be lower, right? Why am I doing negative ln Kw? Because, boss, what is Kw? It is OH minus times H plus. Okay. And then if I take negative log of Kw, that then becomes pH plus POH, because we define, that's how we define pH. pH is what? Negative log of H plus ion concentration. Boss, this theory has to be in your head. And look, by doing all of this, you're guaranteed to get like a full score on chemistry in JEE Main for sure. And that's why we're making so much effort over here. Anyway, ये सब राम कहानी के बाद टेम्परेचर बढ़ाने पे ionization constant of water increases. Okay, that means negative ln Kw will decrease, which means the pH, the neutral pH now will be lower than 7. That is the goal that we are getting to in this 7th question. Yeah, the questions are increasing in difficulty in a way as we move on. Okay, 8th question. Ionization constant of an acid, Ka, is the measure of strength of an acid. Okay, cool. K values of acetic acid, hypochlorous acid, and formic acid. What are the formulae? Oh, formic is easy. Acetic is also easy. What on earth is hypochlorous acid? Hypochlorous. Is it HClO4 or is it HClO3 or is it HClO2? Which one is it? See, I know that P block has been deleted from your syllabus, right? A lot of these reactions, reactions of P block compounds. But you see how stuff is kind of coming back to you from here and there. So it's good to revise some of these things, although the stuff is deleted. You don't need it in this question, but you never know what could be asked in the test. Okay, let's look at these values. Some values are given over here. Or is it something else entirely? I mean, maybe one of these, or is it something else? Okay, hypochlorous acid are given to you. Okay, Ka values are given. Which of the following orders of pH of 0.1 molar of these acids is correct? Oh, okay. Well, that's kind of direct. K value is something. What does K and pH have to do with anything? Okay, let's write it down. HA gives me H plus A minus. Okay, that's my standard equation. So now K is, if I write this as C alpha and C alpha, C into 1 minus alpha. You know these equilibrium setup things, right? I don't think I have to spend too much time on this. 1 minus alpha is going to be equal to this. Let's just write it as this. Let's put C into, let's keep it as it is, because I don't want to cancel out C alpha, right? Because C alpha itself is the H plus 7 concentration. So from that I get C alpha is going to be under root of K into C into 1 minus alpha. Wow, okay, cool, great. Does that make sense? Does that track? So anyway, what we're trying to get at is that pH is going to be negative log of this C alpha, right? That will depend on some root K or whatever. It may depend on that. So, and we've got a negative value there as well, right? Negative log of this as well. So basically what we're trying to say is that if K value is high, then pH will be low. Let's write that. That's the conclusion. If K value is high, then pH is going to be low. Please do this math by yourself, okay? Don't trust me on this. Do this math, be convinced. This is not something to mug, okay? If K value is high, pH must be lower. That is for sure. Okay, cool. What are your K values? Looks like to me formic acid is the strongest acid out of all of these. What do you think? Let me know in the comments on all of these things. Okay, so formic acid, which means I can remove these two. A and B are gone. So it's going to be 3 and 4, among 3 and 4. After formic acid, what is next? Next would be this guy. What's this? What is this? Acetic acid? Yeah. This is the answer. Yeah. So 8 should be option number 4. Let's do the 9th question. K1, Ka2 and Ka3 are respective ionization constants for these reactions. What is the correct relationship between this and this and this? Okay. This is K1, this is Ka2, this is Ka3. So they've done something interesting, something very interesting, right? This seems to be the overall reaction. And if you've paid attention in the theory classes, you'll know that this doesn't happen in one step. It happens in 2 steps. This is step 1, this is step 2. And then you have to add them both together to get to this 3rd step. Now, if you're adding up reactions, you multiply the Ka values. Why? Do it by yourself. Yeah, it's a simple math. So I think this is the expression that tracks. Oh, finally, an easy question after doing all these complicated ones. Okay, this one's very direct. Acidity of BF3 can be explained on the basis of which of these concepts? We are doing this whole Arrhenius, Lewis and all of that. I feel it should be Lewis because BF3 is electron deficient. So the theory that talks about electrons, which should be the Lewis theory in my, I feel it should be the Lewis theory. All of this, Bronsted talks about, one of them talks about H plus OH minus, one of them talks about only H plus. Which one's which? Think about it, okay? You don't have to think about it, it's basic theory, but only one of these are actually is used when you talk about the whole Ka values, especially when organic chemistry. Which one is that? I think you have an idea. Has to do with the Bronsted-Lowry concept itself, yeah, where there is conjugate acid base and all of that. Anyway, let's move on. Which of the following will produce a buffer solution when mixed in equal volumes? Equal volumes. What is a buffer? Strong acid? No. Strong base? No. Oh, weak acid. Okay. Weak acid plus salt of conjugate base, or weak base plus salt of conjugate acid. Okay. What am I talking about? So if I have HA plus A minus, right? This is my weak acid. Or if I have BOH plus B plus, where this is my weak base. That is what we're talking about. An example of this is CH3COO minus. An example of this is, say, NH4 plus. Things that can get hydrolyzed basically. Yeah. Okay. So now with that, when we're armed with that, let's look at these options. Oh, look at that. We have NH4OH, these same, I didn't look at this. So I swear, we have these same options here. CH3CONA, that's the salt. Oh, this is a strong base. This one's off. I'm just going in whatever order. This is a weak, this one's interesting. You've got a weak base and some HCl. Maybe this could work. We'll see. What about this? Oh, so option 2 and 3. I think we've got even the first one. So let's see what happens in all of these. Okay, in the first option, all of them have a weak base and a strong acid. So I think if we neutralize these partially, then we'll get this second case over here, right? Why am I saying partially? If you fully neutralize this, then what you're going to get is just a salt. What salt? This salt, right? You will get, let's say NH4OH and HCl. So you get NH4Cl. That's not good. That's not a buffer. That's just a salt. And you can figure out its pH using hydrolysis, but that's not a buffer for sure. Okay. So we've crossed out option 4, and because of the same reason, we're going to cross out option 1, because this is going to give you a salt, right? You've got the same strength, 0.1 mole per liter, and you've got the same volume, which means you will only get a salt. You don't have any extra. What do you want extra of? You want extra base. Think about it, okay? Think about why I said this. To make a buffer, I need to have weak base and salt of conjugate acid in solution. How am I going to get this salt in this case? I make this neutralization happen. But I don't want to use up all the base. Yeah, some base left behind, which means the base needs to be in excess. Why do I need some base left behind? Again, to get this setup of weak base and salt of conjugate acid. Okay, so I know I've said this multiple times, but I feel that the answer should be option 3 because of this logic. Because now I have excess amount of NH4OH and this, gets consumed fully. Write the expression down. You'll be able to figure this out. Okay, it's not that complicated. It's not rocket science. But since this is practice, so to speak, for JEE and all that, you're supposed to do this pretty quickly. I've explained this in detail, but this doesn't take that much time to think. Maybe it takes a little bit more than the other ones, but not this much time. So say if I take the same volumes, say 1 liter, then I have these many amounts of this, okay, which means that only this much of this gets used up, where this gets used up entirely. So I have got NH4Cl 0.05 moles and 0.05 moles of NH4OH in solution. So there you go. I've got salt of conjugate acid and weak base. Cool. Let's move on to the 12th question. I spent a lot of time on the 11th one. So students sometimes, I know they have issues with these questions. So I thought, why not? Let's spend some time on it. In which of the following solvents is silver chloride most soluble? Most soluble. This is slightly tough. You need to know a little bit of theory on this one. AgCl. Okay. Is it going to be soluble in AgNO3? Not really. It's got a common ion, right? Ag plus and Ag plus. That's going to reduce solubility. AgCl, okay. What about HCl? Again, you've got a common ion. That's not going to track. Yeah. If I want something to be soluble, I want the reaction to go forward. How am I going to get the reaction to go forward? By somehow removing either of these chaps. If I am removing these, then I can force the solubility to increase. But in both of these, I'm either adding Ag or Cl, so that doesn't work. Adding water does not work. Why does aqueous ammonia help? Well, NH3 plus Ag plus gives me a complex. What is the complex? If you have not done this in 12th grade, if you're an 11th grade student, I will not bug you with it. If you're a 12th grade student, you should know this by now. Okay, there is a complex that gets formed, and that's why this Ag plus concentration, well, reduces, so to speak, and the equilibrium moves in the forward direction to increase the solubility. So I feel that the answer should be option 4. Okay, let's look at the 13th question. I know there's a formula to do this, and if you know me, you also know that I'm not a fan of all these formulas. So we'll do this from first principles, right? I've got this set up over here. So if I write this down as initially C, 0 and 0, C into 1 minus alpha, C alpha, C alpha. If I do all of this, then I get K to be equal to C alpha, c square alpha square by c into 1 minus alpha. You will notice that I haven't cancelled anything out, and there's a reason behind this, because under root of c alpha is basically going to be equal to h plus ion concentration, rather under root of c square alpha square, which is c alpha, right? That's what we are getting at, this highlighted thing. Okay, cool. So under root of k into c, I'm going to assume that alpha is much lower than 1, so 1 minus alpha is almost going to be equal to alpha, right? That is what we are assuming. All right, so I think we've pretty much got things sorted out. If you just do this from here, it is possible to solve this. You don't have to spend too much effort here. So you get 1.74 into 10 power minus 5 into 10 power minus 2 and under root of the whole thing. So it's 1.74 into 10 power minus 7, which is a scary thing, right? I mean, 1.7 10 power minus 7, how do you even do that? So let's make it 10 power minus 8. So I'm dividing by 10 and also multiplying with 10. So I get 17.4 into 10 power minus 8. From here, now it looks like this is very doable, right? Because this, if I take negative log of this whole thing, if I call this to be x, negative log of x is going to be equal to 10 power minus 4, sorry, which is equal to 4, right? Because negative log of 10 power minus 8 minus under root of 17.4, let's call it 4. Let's say that is 4, right? Okay. If I say that that is 4, then I can say 4 minus log 4 is what we're going to do. Okay. How much is 4 minus log 4? Let's say that log 4 is 0.3 into 2, because log 2 was 0.3, yeah? So this whole thing into 2, so 0.6. I think we're getting somewhere. 4 minus 0.6, which is 3.4. This is the quickest way to do it, even if you don't remember any formula. So 13th answer should be the first one. What do you think about this method of doing this question? It's important to be able to do things quickly, okay? I don't think something like this is going to come in your exam, because JEE Main and NEET both have become significantly easier these days. But fun question anyway. 14th question. Ka for CS3COH is given and Kb for this is given. What is the pH of ammonium acetate? Again, this is something that can be done from first principles, or you can also do this from, well, the derivation. But in this case, I would suggest that we use the formula here. Doing this from the derivation bit could get a little bit time taking, and this is very, very direct, okay? The idea is that it's going to be 7 plus whatever the difference between these two is. The idea here is that this value is basically Ka of the weak acid and this is Kb of the weak base, right? So 7 plus the difference of these two. The interesting thing here is that both of them are exactly the same, right? It's actually pKa minus pKb, right? It's 14 by 2 plus this whole thing. And it just so happens here that both of these values are equal, so it's going to be exactly neutral. And even if you don't remember the formula in this case, whether it's pKb minus pKa or pKa minus pKb, it doesn't matter so much because the answer is the same. But I would recommend that you go through the theory and figure out where the value is going to lie, okay? It's important, the derivation, for JEE Advanced, but for JEE Main, I think the derivation is not important. If you want, you can just look up the final result on NCERT, but understand why that result comes, okay? It is because these things get hydrolyzed, all right? So please revise the theory about this. Okay, next question. Which of the following options will be correct for stage of half completion of this reaction? Now, what on earth is half completion in the first place? Are you aware of half completion? Is this theory in NCERT or not? Technically, what they're doing these days is asking things directly from NCERT, but the problem is that in NCERT, some things are just given, right? They're just given as a statement of fact. So take it as another statement of fact that half completion is where alpha is equal to 0.5, which means that the concentration of A is going to be equal to concentration of B. And then you say that, hey, K is then going to be equal to 1. Like what? Yeah. K is what? It is concentration of B by A, right? That is K. So if both of them are equal, then K is equal to 1, and then delta G naught is equal to minus RT ln K. If this whole thing is 1, then this whole thing is not 1, sorry. This, if K value is 1, then ln K is going to be equal to 0. So delta G should exactly be delta G naught should be 0, which is like a weird thing. And I know it's the weird thing because delta G naught being 0 is not a normal thing. It's just a mathematical idea here. Okay, let's go to the next one. On increasing the pressure, in which direction will the gas phase reaction proceed to re-establish equilibrium? And that is predicted by figuring out Le Chatelier's principle. Okay, इनमें से कौन सा करेक्ट है? अगर टोटल प्रेशर इक्विलिब्रियम एस्टैब्लिश हो विदाउट जो इंक्रीज किया था विदाउट चेंज इन द टेम्परेचर. सो ओके, कूल. वी आर इंक्रीजिंग प्रेशर एंड टेम्परेचर इज कांस्टेंट. Okay, what is delta Ng? It's going to be 2 minus 3 minus 1, which then becomes negative value, some negative value. If delta Ng is negative, I'm increasing the pressure. Oh, this gets complicated, right? Which way does it go? This is how I remember it. If I increase the pressure, it needs to go in the direction where pressure reduces, which means moles reduces. So I would like the reaction to go in the forward direction. But hold on. None of that matters. That's being tested here. Sure, the reaction may go forward or backward or whatever, but this question is talking about K. K value is not going to change because temperature is constant, right? The reason why I did this question this way is because most students are going to start thinking very quickly, doing this, doing that. I would request you to take a step back. This is one of those questions that is the waste of time, right? Because there's so much text given, you have to figure out what you've got to do. But I would advise you to read the question a couple of times, especially when there's a long question. If there's a trick involved, and this the only thing that you need to do is, bhai, temperature constant hai, to kuch nahi hone wala hai. Nothing's going to happen. That's it. Which of these, next question, will be the correct order of vapor pressure of water, acetone and ether vapor pressure. Vapor pressure, how do we do this? Interesting. So what I've got to do is I've got some liquid becoming a gas, and there is some equilibrium that exists, and this equilibrium exists at all temperatures. You may say that, hey, the boiling thing happens only at boiling point. Sure, but at all temperatures there's some amount of vapor that's always above the gas. I know that states of matter has been deleted from the syllabus, but this idea is very, very valid even now. Okay. So water has a maximum boiling point. If water has a maximum boiling point, that means that its vapor pressure is lower than the others at all temperatures. Why? Because I would say it is less volatile. These ideas will be more clear when you do this chapter called solutions. Okay? For now, an ether has the minimum boiling point, which means it has the highest vapor pressure at all temperatures. You can check this data out on Wikipedia or anywhere else. At all temperatures. This is what this actually means. Okay. Why am I confident about this? Because see, the boiling point idea has to be when atmospheric pressure is equal to vapor pressure. Now I feel like I'm going directly in this direction of solutions, so I will stop. But take it as a statement of fact for now that, look, if something is more volatile, its vapor pressure will be higher than something that is less volatile. And technically, I can argue that this is the idea of physical equilibrium, hence this could belong here, but this question is better asked in the solutions chapter if you ask me. Anyway, what is the question? Correct order of vapor pressure. Oh, that was the question. Okay, great. So water must be the least and ether must be the highest. The logic is here, but yeah, this question is, I think, better served in that chapter. My opinion. Next question. At 500 Kelvin, equilibrium constant is given to be some value. What will be the equilibrium constant? Oh my God, this is such a fun question because it's so easy. All I've got to do is reverse the reaction and then multiply with 2. Okay, reversing matlab K dash becomes 1 by K into 2 means it gets squared. Let me call it K double dash. Right, so 1 by K dash squared, 1 by K square. Okay, so 1 by 5, oops, what are we doing? 1 by 5 square becomes 1 by 25, that then becomes 100 by 25 into 100. I'm just doing baby steps. 4 by 100 should be 0.04, right? Simple stuff. Let's move on to the next one. In which of the following reactions the equilibrium remains unaffected on addition of small amount of argon at constant volume? Whoa, interesting. This is a cool question. because of two reasons. We're adding an inert gas, okay, and we're doing it at constant volume. Now, if I do something at constant volume, will something change or not? Will the whole K expression change or not? The key to answering this is that check if partial pressure changes. If partial pressure does not change, then nothing will happen. If partial pressure changes, then you go in this whole direction of delta N, G and all of that and this and that. Okay, let's take a simple example. Maybe this is going into theory a little bit. I have some A giving B. I have 1 mole of each randomly, and I add 1 more mole of, say, argon into this mixture. Let's see if partial pressure changes. So in this case, total pressure is 2 atmosphere. Let's just say it randomly. Not 1 mole, let's say this is 1 atmosphere, and I add argon at another, enough argon to add that by increase the pressure by 1 more atmosphere. Okay. So total is 2. So initially partial pressure, the mole fraction was 1 by 2. Total pressure was this. And this is the partial pressure, 1 atmosphere. This is how you do this, right? Now, when I add this third thing, argon, into the mix, what happens here? The total pressure now becomes 3 atmosphere, right? P total. But the mole fraction also changes, right? Because I had 1 plus 1 plus 1 plus 1. So denominator increased and the numerator increased by the same amount, right? Which means that the partial pressure was the same. This is the best way to see what happens when the volume is constant, because only when the volume is constant will pressure increase. Okay. I have done these derivations in the theory class, you can check it out, but if you forget, in case you forget this in a test, this is a quick way to check. So at constant volume, nothing happens because partial pressure remains unaffected. Okay. Hence 19th, 4th is the answer. Whew. We've covered up. Oh, we've got a couple more questions. We've covered all the single answer correct questions, just a couple of more to go. For the reaction N2O4 giving this, the value of K is some value. The reaction is endothermic. Yeah, sure, absolutely. It's endothermic for sure because I'm increasing temperature and volume is, and the K value changes. Okay. Which means this is wrong. Okay, so I think for this I'll have to figure out what is the K value. 400 Kelvin, which is this temperature, which is this K value, pressures of 20 and 2. What do I have here? Okay, 20 is NO2. Okay, so I've got 2 square by 20. That is the K value. Okay, so now, not K, sorry, Q. So Q is significantly lower than K, which means that the reaction should go forward, and that's what this is saying. So this is correct. What about this last one? Entropy of system increases? Yeah, sure. I increase temperature, entropy will increase. It is true that S is Q reversible by T. What this is trying to say is that as the temperature increases, the amount of entropy, which is delta S, will decrease, but on increasing temperature, entropy will increase. So this is cool. So I think 1, 3 and 4 all are correct. Last idea here. At a particular temperature and atmospheric pressure, the solid and liquid phases of a pure substance can exist in equilibrium. Which term defines this temperature? Solid, liquid will coexist. Melting point, right? Should be just melting point and freezing point. These are the answers to this one.